Example 3, find all fourth roots of negative 8 plus 8i squared. So I would rewrite this problem as x to the fourth equals. It's not something that's totally necessary, but I think it really helps to visualize what we're doing. We're solving this equation. So we're going to end up taking the fourth root of both sides. But we have to change the polar first. So let's change the polar first. We want r and theta, so r is going to equal negative 8 squared, square root of negative 8 squared plus 8 radical 3 squared. Okay, be really careful when you type this in on a calculator. Okay, if you don't put parentheses in here, your calculator's going to think this first part's negative 64, when it's actually positive 64. We have 64 plus 64 times 3 in there, which is 256. We've got the square root of 256, which is 16. R is 16. So then we also need theta. Tangent theta equals the y part over the x part. And so these 8s would cancel, and I'm looking at tangent theta equals negative square root of 3. And so look at your chart. What angle is going to give me that square root of 3? It's going to be 60. Good. So we're looking at 60 degrees where tangent is negative. Okay? So we would know that it's either quadrant 2 or 4. But just look at the problem. Negative 8 and positive 8 square root of 3. That means your x is negative and your y is positive. Which quadrant does that have to be in?
Second.
That's the quadrant 2. Good. So a 60-degree reference in quadrant 2 means that theta is 120. Long story short, we just converted. We've got x to the fourth equals, and instead of that negative 8 plus 8i squared of 3, we've got 16 cis 120. Same thing. Those are the exact same vector. So if I'm going to use my nth root here, I'm going to take the fourth root. Fourth root of 16 is 2, and you'd have 120 divided by 4 is 30. So 2 cis 30. One of my solutions, one of my roots, is 2 cis 30. Now remember, there are going to be 4 solutions. Okay, x to the fourth equals shows me there are going to be 4 complex numbers here. I've got the first one. In order to get the others, you're going to say, well, if there are 4 vectors in the plane, then they must be 90 degrees apart from each other. I know those 4 things are 90 degrees apart from each other, so let's add 90. We have 2 cis 120. Add 90, we have 2 cis 210. Add 90, we get 2 cis 300. And those are your answers. Those are your answers. We're just not in the right form. This problem, again, asks me to put it in rectangle. And so your answer has to be x plus iy. X plus iy. And that's the hard part for me. Okay? You have to be able to convert all of those and use the chart on all of those and get them into rectangular form. So let's look at this one. You would have 2 cosine 30 degrees plus I times 2 sine 30 degrees. Hopefully that one's easy for you since that's straight out of the chart. Cosine 30 is square root of 3 over 2, and sine 30 is 1/2. So once you clean that up, cancel the 2's, you're looking at square root of 3 plus I. That's one of my vectors, one of my solutions. And so then we try another one. Okay, let's try this one. We would have 2 cosine 120 plus I times 2 sine 120. Okay, so cosine 120. Let's think about where 120 is. 120 is going to be a 60-degree reference in the second quadrant. So look at cosine 60. Cosine 60 is 1/2. So what's cosine 120? Negative 1/2. Very good. And sine 60 would be square root of 3 over 2. So sine 120, we're in the second quadrant, is also going to be positive square root of 3 over 2. So again, let's cancel out those 2's. I'm looking at negative 1 plus I times the square root of 3. Okay, let's try this one. 2 cis 210. I'm going to have 2 cosine 210 plus I times 2 sine 210. 210 is going to be a 30-degree reference in the third quadrant. So cosine 210 has to do with cosine 30. Cosine 30 is square root of 3 over 2. What's cosine 210? Negative square root of 3 over 2. Do that right? Sine 210. Sine 30 is 1/2. So what's sine 210? Negative 1/2. Cancel the 2's. I have negative square root of 3 minus I. And then we have to do this last one. 2 cis 300. So 2 cosine 300 plus I times 2 sine 300. And so 300 is a 60-degree reference in the fourth quadrant. So you got to do cosine 60. Okay? Cosine 60 is 1/2. Cosine 300 is what? Not quite. If cosine 60 is 1/2, what's cosine 300? Also positive 1/2. Fourth quadrant, cosine numbers are positive. Okay? Sine 300, so do sine 60. Notice that's in the fourth quadrant. Sine 60 would be square root of 3 over 2. But what do we know about the fourth quadrant? That's going to be negative. So cancel your 2's. Cancel your 2's. I have 1 minus I times the square root of 3. We got 4 answers, 4 vectors in rectangular form. Okay? Look at what's hard about this problem. It's not this. It's not this. This is the easy part. This is the new material. This is where we're doing the nth root theorem. That's the easy part. Hard part is converting it back to rectangular at the end and using your charts.